In this example, we have found how to design the logical model of a retail financial banking system. We use the tool Erwin. We know how bank and branches are connected, how branch managers are connected, how employee and supervisors are connected, how the relation between customer and account, how to set up a transaction limit, how to create constraints. All this really helped us to build a proper logical model. From here, we will take to physical model, and from there, we will forward engineer. Hello, friends. Welcome back to Learn with Biju. In my today's D&A talks, I would like to show you how to develop a logical data model using Erwin Data Modeler Tool. Let's start. Yes, it is time to take up our use case. We have a set of requirements for developing a banking retail information system. We need to analyze this required logical model. We will follow a process. Let's take the requirement line by line. If you identify any potential entity, we shall mark them. Then we will create those entities in the data model. The first step is identifying entities. So bank offers savings or current accounts. Bank is an entity. Savings or current account is another entity. Bank has multiple branches. Is branches is an entity? Yes, branches is another entity. Each bank branch has branch manager. Of course, branch manager is another entity. Each bank employee of the bank has supervisor. So employee is an entity and supervisor is another entity. Bank customer can open multiple accounts. Of course, bank customer is another entity. Customer can deposit or withdraw cash from accounts. So this is nothing but a transaction. Customer is not allowed to deposit or withdraw more than 1 lakh in a single transaction. This is also a constraint. This is not an entity, it is a constraint. A bank account is always open in a specific branch. It's an association of bank account and a specific branch. A branch bank customer can subscribe transaction notifications in email, phone, or address. So these are nothing but attributes. They are not entities. Okay, let's move on. So if you look at high level, so we have a bank entity, we have employee entity, we have supervisor, we have customer, then we have branch, then we have branch manager, we have a transaction, and we have account. So these are the main entities that we are going to model in our tool. Let's go back to our tool. For modeling our use case, I'm going to use Erwin Data Modeler. I have already installed Erwin Data Modeler in my virtual environment. This is a standard trial version. And I'm simply going to create a new model. As you already aware, we have options. What should be the new model? Should be logical, physical, or logical, physical, or matching to some template. So remember, logical model has no physical implementation associated with it, and therefore we are not having any option to choose a database or version of the database. However, when you choose whereas when you choose physical model, we have option to choose database We have lot of databases as destination, and we can have various available versions of that database as well. If we choose logical physical, yes, of course, this provides you database options as well as the version option. I would like to create logical physical model for this use case. Let me click OK. Now we are going to have a blank new model. Once it is created, we will quickly cover some of the UI aspects, which is very much needed for completing this exercise. First thing first, we have a blank model. There is nothing we have created yet in this model. But if you look at the model explorer, you have a lot of options you are seeing. You know, we have a physical model and we have a logical model. And as you already discussed, for the logical model, the options are very few. Whereas for the physical model, options are many. Every physical model has a real time implementation associated with it. Before we actually implement the model, let's have a quick tour of the model explorer. See, we have model explorer, and for logical model, we have set of options, and for physical model, we have another set of options. Okay, and why this difference? I think you already know that because the physical model has a real-time implementation associated with it. It will have a database, it will have some specific version of the database, and along the database, you will need to create lot of things like schema, script template, logins. Then we have the default values. Then we have stored procedures, triggers, sequences, and we have the data movement rules, and we have even create data vault 2.2, and we have audit specifications, database encryption keys. All these are possible with these physical model. But when it comes to a logical model, we have only limited options available. We can have domains, entities, ER diagram, model sources, naming standards, relationship, subject area, themes, some validation rules, and data type standards, and so on. So now we are not going to explain each and every options now. We are not going to see them in detail now. We can go through them one by one as we progress in our data modeling. So I am focusing on building our first data model, that is a retail banking system using logical model. We are all set for building our first data model. I'm using the tool Erwin, and already we mentioned that we can create logical model or physical model. Let me start with logical model. In the model explorer, we have a model 1, and we have entities, then we have ER diagram. By default, an ER. So let's start creating entities. Let's start adding entities. So what are the entities we will need to add? Let's create the first entity, which is bank. Bank offers savings or current account. So this bank entity is created. Then we have account. Then we have branch. Then each branch manager. The of the bank has a supervisor. So let's do an employee. Then bank customer can open multiple accounts. So customer is another entity. Then customer can deposit or withdraw transaction cash from accounts. Customer is not allowed to deposit or withdraw more than 1 lakh in a single transaction, which is not a entity. Then bank account is always opened in a specific branch. So there is no entity. So bank customer can subscribe transaction notification in email, phone, address. There is also no entity to be created. So we have created the basic entities for our retail banking information system. So what is next? Let's add these entities to the ER diagram. I am adding bank to the ER diagram, adding branch to the ER diagram, adding customer to the ER diagram, and we have employee to the ER diagram. Let's try to arrange them. So we have branch, we have bank, branch, account, branch manager, customer, and employee. So this, if you need more, we can create later as well. So let's start adding some attributes. So let's create attributes. For creating the attributes, you can right click on the entity and we have options to manage each and every entity. So entity, you can right click and check entity properties. So it gives you all the entities and we can manage style, icon, history, notes, all things can be managed in this editor. Okay, you can even create a new entity through this entity editor. So I'm not going to make any changes. So what we are going to do is we are going to add some attributes to the bank. Okay, so this is a attribute editor. So we have option to create new attribute. We can delete attributes, then reset order options are there. Then we can do general settings. We can set up image. Then we can do constraints. We can do linking. We can do key group style, definition, history. All things can be managed using this editor. So I'm just going to create few attributes. So first attribute is bank ID. Bank ID. So by default, the logical data type will be character 18 by default. Okay. So we can set bank ID as a primary key if you need it. And we have options to set foreign key, then logical only, PII, definition, etc. So first attribute is created and I have set the status to primary key. Then I can create a bank name. So I'm not going to change anything. By default, it takes character 18 as the data type. Then we have bank address. So this is the only minimum attributes I am going to create for this bank. Okay. So this is how the entity appears in the Erwin Data Modeler. So we have bank entity, the primary key bank ID, then non-primary keys like bank name, address, etc. will be displayed like this. Okay. Similarly, we can create properties for other entities. I will just quickly complete managing the attributes and come back quickly. Come back quickly. I am done with adding properties to all the entities. So you can see that for the branch we have branch code and we have the location and the AFSC. Then for employee we have the required attributes: employee ID, employee name, date of birth, joining address, age, and customer also customer ID, customer name, email, phone address, etc. So this is the logical model. This is under logical model. This is called entities, and if you change to physical model, this will be appearing under tables. If you look at the tables, this is all tables like account table, branch manager table, bank table, branch table, customer table, employee table. So in physical model, entities are called tables. Okay, so we have not assigned any relationship, so we don't see any relationship as such. Okay, so let's continue assigning relationship now. Let's go back to the logical model. Now we are back to the logical model and we are going to create a relationship between these entities. First of all, we will take a bank and branch. What is the relationship between bank and branch? Every head office will have multiple branches, and branch will have a branch code, it will have a location, it will have an IFSC code. So let's try to add a relationship. For that, I will drag the non-identifying settings on the top of the bank and to the branch. Yes, it has created a relationship. Okay, you can just double click on the relationship and we can understand the properties of this relationship. You know, it is a type non-identifying. Null option is null is allowed. Can can a null be allowed here? because every branch should have a main office, right? So this option is not right. So we cannot allow null in this case. So let's not allow null. Now the relationship is redefined. The bank will have multiple branches or no branches. Nothing is mandatory, right? But every branch should have a main office. So that is what is represented here. So we have set the first relationship between bank and branch. And you know that the branch code is a primary key in the case, and bank ID is a foreign key. And we are not allowing a null for the bank ID. Understood? Let's move on. Next, every branch has a branch manager. So if I want to connect from employee to a branch, so what are the challenges? Can I directly throw a relationship from branch employee to branch? What if if the manager changes? How to track the change history, change log? So for that, we can create a new entity called branch manager. Then we can make relationship from branch and employee. Okay, let's try to add a relationship from branch to the branch manager. Let's create a relationship. So we can again set the properties to not null, because we need branch manager to be part of a branch, and we can set another relationship from employee to the branch. So basically this also employee, we cannot allow null. So we can make the branch code, and we can make this branch code and employee ID and the start dates as the primary key, right? So what's the benefit if a branch has new managers? We can track them by branch code and employee ID and start date. The same person can be the same employee can be a branch manager multiple times over period of time. So we have a relationship from branch and employee to branch manager entity. Hope this is understood. Yeah, going forward, moving forward, the next relationship we need to make is between employee and a supervisor. Each bank employee of the bank has a supervisor. So how do you do that? So we have an employee entity and we don't have any supervising entity. So already we've seen that we can have a recursive relationship to represent a employee supervisor relationship. But what if the What if when an employee has different supervisors and same employee supervises an employee at different point of time? So we can create another entity called supervisor. Let's add a supervisor entity and add to our diagram. It's added. So we have added a new entity called supervisor. We have not set any relationship. So in the supervisor entity, what all things will be there? We will have an employee ID and the ID of the supervisor. So how to create an relationship from employee? So let's create a relation from employee to the supervisor. So this relationship is basically represent the employee relation between supervisor and employee. So let's create one more relationship. That's again employee to supervisor. How we need to basically create a role for this. For that, you go to the properties. Then there is a, something called role assignment. Let's rename to supervisor ID. So we have the employee ID and supervisor ID. Both are primary key as well as foreign key. So let's add two more additional attributes. We can add a start date, and we can add end date as well. So this is, let's move the start date to the primary key. So the employee ID, supervisor ID, and start date. Okay, these three combination of keys will give you a primary key. So we have set relationship from employee to supervisor, and this represent every employee has a supervisor. Okay, so that is also completed now. Next is a customer can open multiple accounts. So we already have entity customer and we already have another entity account. So how do we relate customer to account? Let's have a relationship. Okay. So we set a relationship from customer to account. But account, from an account point of view, every account should have a customer, right? So we should not allow null. So we have the relation from customer to account. And also, we should know every account will be open in a branch. So we will have a relation from branch to a account. So we have account. Account has a customer. Account has a branch code. So what's the primary key? Account number is a primary key, and account type, customer ID, branch code. So let's look into the requirement a little more closely. What additional things we need to set up? A bank customer can deposit or withdraw cash from accounts. So the customer can withdraw cash from accounts. And there is also one more constraint. A bank customer is not allowed to deposit or withdraw more than 50,000, 1 lakh in a single transaction. A bank customer is not allowed to deposit or withdraw more than 1 lakh in a single transaction. Okay, so we will need a transaction entity. Okay, let's create a transaction entity. Let's add to the diagram. We have a transaction entity. The transaction entity, we will add transaction ID, TXN ID as primary key. Then we will add TXN date, TXN date, transaction date, amount, TXN amount. Then we can say account number. Okay, okay, let's close this. Every account, so we will have to make a relation from account. Okay, so let's create an account. So account number is a foreign key, and every account can make transactions. Okay, so a transaction should have an account, right? So we will also make this as mandatory. Okay, this is mandatory. We have almost done with the logical data modeling, but there is one thing pending, is that you need to assign a constraint to the transaction amount to 50,000. For that, we can simply select the transaction amount attribute in the entity, and we can create constraint. Okay, let's choose a new constraint. We can choose, there are different types of constraint. You can go user defined, min max, and varied values. So let's do min max. It gives you an option to choose the minimum value of the transaction allowed and maximum value of the transaction assigned. Let's set this maximum value to 50,000 and minimum value to 1. So the customer can do transaction from 1 rupees to 50,000. Okay, this is the transaction constraint. Okay, apply let's apply. So the transaction limit also is applied. In this example, we have found how to design the logical model of a retail financial banking system. We use the tool Erwin. We know how bank and branches are connected, how branch managers are connected, how employee and supervisors are connected, how the relation between customer and account, how to set up a transaction limit, how to create constraints. All this really helped us to build a proper logical model. From here, we will take to physical model, and from there, we will forward engineer to the database. That we will see in the next class.